right, a growth mindset, math side, Panthers. This is a lesson continuation where we left off right around here for both classes, thereabouts, and packing fractional cubes into a larger rectangular prisms. So this is where we left off, and the guess is here, what's your hypothesis as to how many of these doohickeys with a cube with a half-inch length here, that means they're all half-inch lengths, right? How many of these will fit into this kind of container here, this prism, rectangular prism that has dimensions of 5, 2, and 1, 5 centimeter, 2 centimeter, 1 centimeter. What do you think? How many will fit in there? Quite a bit, it looks like. Let's keep going and find out. Let's do the math, shall we? First, we got to determine the volume because it says right up here the formula is V times F equals T. V stands for volume, so let's do it. The volume of the object that we're putting stuff into. Let's see, 2 times 1 times 5. See, we got 2 times 1 times 5, length times width times height, is 2 times 5, which is 10 centimeters cubed. That means we can fit 10 of these things in here, right? This size. Just keep in mind that we're not looking at 4. We're looking at this filled in, and filled in. So that's a 1 by a 1 by a 1 at any rate. Well, actually, we are going to be looking at 4 because 4 of those go into here. So if 4 of those go into here and 10 of these go into here, then how many of these go into here? Think about it. Let's take a closer look. So we take the 10, which is the 10 cubes, right? 10 cubes. And each one of these holds how many of these? We said it holds, 8. I'm sorry, 4 in the back and 4 in the front. It holds 8. So we need an 8 here. There's 8 in each one of these. So what's the total number of cubes that'll fit into all of this rectangular prism? There's 10 eights. We have 8 10 times. Therefore, we are going to multiply 10 times what? F. What's F? Fractional cubes per unit cube. This is the unit cube. This is the fractional cube. How many fit in the unit cube is what we're multiplying by here, which is 8. And of course, 10 times 8 is 80. That means we can fit 80 of these things in here. That's a lot, right? Can you imagine trying to draw 80 of these things? Yeah, I'm not going to even go there. Okay, let's just keep going. By the way, I think I misdrew that, because if I were to draw this more properly, I think it would be like, if there's 2, I'm not going to think about it. All right, never mind. Too much thinking right now. Let's just continue on with this presentation. Let's move this over. A little extra room to draw on. All right, so this is the 3rd-inch length cubes, right? So remember, we could fit, what was it, 4 of these in here. How many of these do you think we're going to fit in here? What's your hypothesis? Well, you can't type it in the chat because we're not live right now. But type it in your brain. Well, maybe not, so to speak. That's a metaphor. Don't take that literally. Well, I could do the little math to try to find out. Take the length times the width times the height, and what do we get? That's 1/9 here. Well, don't remember, we got to do this 1/3, and 1/9 times 1/3 is 1/27. I mean, if you want to go straight across, you can. 1 times 1 is 1. 9 times 3 is 27. That means that this, well, what does that mean? This is called a 1/27th cube. This is called a 1 cubic centimeter. This is a 1/27th cubic centimeter. How many of these 1/27ths fit into one of these? Well, you could kind of add them up until you get to 27 of them. 1/27 all the way to 27/27ths equals 1. So, okay, so we can fit 27 of them in there. Or you can say, how many times does 1/27th go into, or in other words, fit into 1? Well, that's the same thing as 1 divided by 1/27th. A 1 divided by 1/27th. And of course, 1 divided by 1/27th is a fraction here. It could be 1 over 1, whatever. When you divide fractions as easy as pi, flip the second and multiply. We're just flipping it. So we, instead of 21 over 27, we take 27 over 1, which is really just 27. And 1 times 27 is 27. So we could fit 27, and you could find out, you could find these cubes somewhere, and they do have math manipulatives. If you're in the classroom, you'd be like putting them together. Well, probably not, because not every teacher has them, and not every teacher trusts the students to have them either. Sorry guys, it's just how it rolls sometimes. So wait, what have I done here? I've gotten like, how many in the back? 1, 2, 3, 4, 5, 6, 7, 8. And there's one right there, 9, right? So let's see, what does that look like? So there's 9 in the back, and then so like, that's the orange row. There's 9 orange ones, 9 orange. So how many blue ones we're gonna have? 9 blue ones, and then 9 green ones, and that's gonna fill it up all the way, right? So that's 27, because 9 plus 9 plus 9 equals 27. Or you could say that we have 9 1, 2, 3 times. So it's 9 times 3, which is 27. Okay, so now, so the fraction cubes per unit for this was 8. So the fraction cubes per unit for this that fits into a unit cube is, we just said 27. 27. That means 27 fits into each box, right? Each unit box, each unit cube, I should say, box. And remember, the volumes we already calculated. The volume for this one is 8, the volume for this one is 12, and the volume for this one is 10. 10 cubes in here, 12 cubes in here, 6 in the front, 6 in the back, 6 green, 6 orange. 8 cubes here, 4 in the front, 4 in the back. So let's take that and multiply, right? What's the volume? Take the volume of this one. If we want to see how many of 1/3 cubes inch goes into here, take the volume, which is 8 for this one, and multiply by 27. There's 27 in each cube, 27 of these in each cube. And that is, if you do the math, 216. Wow, 216 will go into this 2 by 2 by 2. How many will go into here? Just pause the video. Pause the video. Come on. Don't make me tell bad dad jokes again about bears walking into restaurants. Really? Okay, there's 12. What's the number of cubes per unit cube? How many of these go into the unit cube over here, the 1 by 1 by 1? Whoa, my PowerPoint's acting up here. There it goes. And that's, of course, 27. As we can see, 27 in the green ones, and then there's 27 in each orange one in the back there. And so multiply that out. 324 go in there. How about this one? Can you do this one? Can you intuitively do it? Can you kind of do it like just kind of, well, there's 27 10 times, right? We have 10 of them. Oh my goodness. My computer's acting funny. I wonder if you saw that everything turned black there for a second. Oh well, let's keep going. Okay, so 10 times 27, 270 of these little 1/3 edge length cubes will go in there. And now we're kind of switching gears. So let's just quick review. How many of these 1/2 inch cubes go into a unit cube? You remember? That's 8. How many 1/3 inch edge length cubes go into a unit cube? 27. So you could think about this as 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Oh, what about this one then? What about this one? How many of these little tiny itty bitty things are going to go in there? Take a guess. Ready? If we follow the same pattern, isn't it 4 times 4 times 4? 4 times 4 times 4? 4 times 4 is 16, but remember, we still got to multiply by this one. So what's 16 times 4? Do you know it? Do you? Do. Oh yeah, it's technically 1/16. Remember that, because we're really getting down to, what's 1/60. This is 1/64th of this, one little tiny piece. That means we need 64 of them to fill up the whole thing. Yeah, I'm not going to do this all the way through. Because if you see here, since it's a fourth, this is 1/4 of the distance from here to here. This is 1/4. This is 1/4. So it takes 4 of those to go across to equal 1. It's also going to take 4 going this way, and it's going to take 4 going up and down. Those are your 3 dimensions, right? Your 4 times 4 times 4, which really 1/4 times 1/4 times 1/4. Okay, so let's fill up the front. If you fill up the front of this thing, and PowerPoint's kind of being a little bit sluggish. It is 4 o'clock, 4:17 in the afternoon, so it's probably like, Mr. Hoffman, it's time for us to, it's almost quitting time. I'm getting tired. Can we stop early? I'm like, no, we got to make this video. Kids are waiting. They need it. Come on, time's a ticking. Let's go. Take your time. Hurry up. Let's see, what's a song I can sing while we're waiting? 12, 24, 36, 48, 60, 72, 84, 96, 108. Oh, now it did something really weird. 120. That's great. And 132 and 144. Do I do it again? Come on now. 12, 24, 36, 48, 60, 72, 84, 96, 108, 120. That's great. And 100, 32 and 144. Oh, how about that? I got to sing the multiples of 12 song twice. And I think we're back in business here. So, filling it up. So you could have just did what, 4 times 4, right? Which really 1/4. But at any rate, how many do we got? 16 there. That's just one of the, I guess, columns, if you will. Like, I don't know. It could be like the base, but I'm actually doing the back, like if you were to turn it. So there's 16 plus another 16 plus another 16 plus one more 16 will fit in there. That's 4 16s. So yeah, see, we're going to multiply that by 4. So the volume, not the volume, it's how many can fit in there, is 64. 64 of them puppies will fit in there. This is 1/64. Yeah. I think, did we do this? I feel like this is, like we might have done this already. Fit into, so 1/64 goes into 1 how many times? We can say 1 divided by 1/64, which is, flip it, right? Flip the script. Dividing fractions is easy as pie. Flip the second and multiply, which is really 64. There it is. All right, let's do this. So we say 64 go into there. All right, so how many go into here, this first one? We already have the volume. Volume times the number of the fractional cubes that go into here. So it's just 8 times 64. 512. I should have let you do it, darn it. I should have said pause for the cause. Okay, no pause on this next one. You do this one. Pause. Okay, did you get it? Here it is. 12 times 64 is 768. All right, last one. Well, so 768 of these tiny little things will fit into all of this. Next, how about this one? How many are going to fit inside there? Oh, 10 times 64 is 640. I love the 10s and the zeros. That's always fun to multiply those. Okay, here's the next kind of problem you need to know. A prism is filled full with 16 cubes that have an edge length of 1/2 inch. What is the volume of the prism? I'm going to stop here, and you could watch this on the next video. Yeah.